Hello, this video is for Algebra 1, Chapter 3, Lesson 2. The lesson is titled Solving Inequalities by Adding or Subtracting. The objectives for this lesson are to solve one-step inequalities by using addition and also to solve one-step inequalities by using subtraction. So who uses this? Well, you can use inequalities to determine how many more photos you can take. So over here we have a young lady taking a picture of her friends here at the zoo, and I guess her name is Tania. Tania has a cell phone that also takes pictures. After taking some photos, Tania can use a one-step inequality to determine how many more photos she can take. Solving one-step inequalities is much like solving one-step equations. To solve an inequality, you need to isolate the variable using the properties of inequality and inverse operations. So properties of inequality sound familiar? Well, we went through a whole section in another chapter where we talked about the properties of equality, and we pretty much, with properties of equality, we used inverse operations to solve equations. So now we're going to do the exact same thing. We're going to use some properties of inequalities, use inverse operations to solve, well, in this case, inequalities. Now, you might be looking at this phone this young lady's holding. In our day and time, I think this shows the age of this textbook that these images came from. She has an old flip phone there, and I don't think it holds too many pictures. Nothing like a smartphone that we have today. So let's go ahead and look at our properties of inequality, starting with addition and subtraction. In words, we say you can add the same number to both sides of an equality and the statement will be true. This is just like you can add the same value to each side of an equation and the equation would still be true. It would still be equal. And inequalities are the same way. An example is 3 is less than 8. And if we add 2 to both sides, 3 plus 2 is 5. And 8 plus 2 is 10, we still see that 5 is less than 10. So we start off with the true statement, 3 is less than 8, and we end up with the true statement that 5 is indeed less than 10. In algebra, we say that if A is less than B, then adding C to A would be less than adding C to B. On we move to subtraction. You can subtract the same number from both sides of an equality, and the statement will still be true. For example, 9 is less than 12. Well, if we go ahead and subtract 5 from each side, we'd have 9 minus 5 is 4, and 12 minus 5 is 7, and indeed 4 is less than 7. So we start with a true statement of 9 is less than 12, add 5 to both sides, and we still have a true statement that 4 is indeed less than 7. In algebra, we would say that if A is less than B, and we subtract the value of C from both sides, that A minus C would still be less than B minus C. Note that these properties are also true for inequalities that use the other symbols. You'll notice in our two examples, both the examples used the less than symbol. But this also holds true for all greater than or equal to, and less than or equal to. Moving along, in example 1, let's use addition and subtraction to solve some inequalities. So solve each inequality and graph the solutions. Note over here in the helpful hint, it tells us to use inverse operation to undo the operation in an inequality. If the inequality contains addition, we're going to use subtraction to undo the addition. And likewise, if it's using addition, then we'll use subtraction to undo the addition. Sounds a lot like equations, don't it? So if you were good at solving equations, you'll probably do pretty well at solving inequalities. So solve each inequality and graph the solutions. So we start off with x plus 9 is less than 15. Well, the 9 is tied to the x through addition. So let's go ahead and get rid of the positive 9 with a negative 9. And what we do to one side, we're going to do to the other. The positive 9 and negative 9 will cancel each other, leaving us with just x on the left. And 15 minus 9 is 6. So we end up with a statement that x is less than 6. If we go and graph that, let's find our point 6. Here's our point 6. It should be an open point because it's less than, not equal to. So 6 is not part of the solution, so we want an open point. And then notice that our variable is on the left. Talked about this in a former lesson. That if our variable is on the left, then the symbol actually tells us which way our arrow on our graph should go. So x is less than 6. It looks like an arrow going to the left. And indeed, everything to the left of 6 is less than 6. So this is a graph of all the possible solutions for the inequality x plus 9 is less than 15. For b, we have d minus 3 is greater than negative 6. So we have this negative 3 here, or you could say that the 3 is tied to the d through subtraction. So let's use addition to undo it. We're going to add the very number we wish to get rid of, which in this case is 3. And what we do to one side, we're going to do to the other. The negative 3, the positive 3 are going to cancel each other out, and we're going to end up with d. And negative 6 plus 3 is negative 3. So we get a solution of d is greater than negative 3. So let's find negative 3 on the number line. Here it is here. It should be an open dot because notice this is greater than, not greater than or equal to. So negative 3 is not a solution for this, so we'll use an open dot. And also, my variable's on the left, so I can use the arrow. The symbol is a hint of which way my arrow on the graph should go. And that works out well because everything to the right of negative 3 is indeed greater than negative 3. So anything we selected here for the value of d would indeed be greater than negative 3. For c, we're going to solve each inequality and graph the solution. So this was from another page. That's why they gave us the instructions again. But this is still example 1, part C. Dealing with decimals here, no biggie though. 0.7 is greater than or equal to n minus 0.4. So this time, notice that our variable is over on the left, right? So, or on the right this time. So we can go ahead and solve it with it on the right. It doesn't have to be over on the left. So we have 0.4 tied to the n through subtraction. And looks like we went ahead, oh, they just rewrite it here. I thought we were going from step to step. So let's go ahead and go to this line here. So we have the 0.4 tied to the n through subtraction. The opposite operation is addition. We're going to add the very number we wish to get rid of, which is 0.4. And what I do to the right side, I'm going to do to the left side as well. The negative 0.4 and the positive 0.4 cancel each other out, leaving me with just n. And 0.7 plus 0.4 equals 1.1. So I end up with 1.1 is greater than or equal to n. Now, like I said, we talked about this in another lesson that if our variable were on the left instead of the right, we could use the symbol to tell us which way to draw the arrow. So what the textbook's done here is instead of having 1.1 is greater than or equal to n, they flipped it around. The n is now on the left instead of the right. The 1.1 is on the right instead of the left. And notice they've also flipped the sign. It was pointing at n, and it's still pointing at n. So 1.1 is greater than or equal to n is the same thing as saying n is less than or equal to 1.1. So whenever it comes to graphing, good clue or good practice to get into is if your variable is on the right, go ahead and flip the whole statement around so that it's on the left. Then you know which way to make your arrow for the graph. So let's find that 1.1. That would be right here, just to the right of 1. It is or equal to, so 1.1 is a solution, so we're going to use a closed dot. And then everything to the left, because everything to the left of 1.1 is less than 1.1. We know that n is less than or equal to 1.1. Moving along, since there can be an infinite number of solutions to an inequality, it's not possible to check all the solutions. What they're referring to here is whenever we work with equations, as teachers, we always say, hey, be sure to plug your solution back into the equation and check it and make sure you got the right answer. Well, truth be told, with inequalities, there are infinite numbers of solutions, so you can't check them all. You can check the endpoint and the direction of the inequality symbol. The solution of x plus 9 is less than 15 are given by x is less than 6. So first, step 1 is to check and make sure that you have the correct endpoint. By doing that, we're going to substitute 6 for x in a related equation, x plus 9 equals 15. Notice that we've done an equation instead of an inequality. Remember, we're just checking the endpoint, so we're going to go ahead and write it as an equation. The endpoint should be a solution of the equation. So here, x plus 9 equals 15. Let's plug in 6. 6 plus 9 is 15. Indeed, it checks out. 15 does equal 15. So by doing so, we know that we have the correct endpoint. The endpoint is indeed 6. Step 2, to check the inequality symbol, is to substitute a number that is less than 6 for x in the original inequality. The number you choose should be a solution of the inequality. And we know that a solution of an inequality is any value that makes the inequality statement true. So x plus 9 is less than 15. Let's think of a number less than 6. How about 4? Plug in 4. 4 plus 9 is 13. Is 13 less than 15? Indeed, that is true, so we know that indeed our inequality symbol is correct. Example 2, here's Tania and her phone. Notice it can only take 20 pictures. Show me a phone that can only take 20 pictures today. The memory in Tania's camera phone allows her to take up to 20 pictures. Tania has already taken 16 pictures. Write, solve, and graph an inequality to show how many more pictures Tania could take. Well, first step is to understand the problem. Well, the answer will be an inequality and a graph that shows all the possible numbers of pictures that Tania can still take. Let's list the important information. First, we know that Tania can take up to, or at most, 20 pictures. The most pictures that her phone will take are 20. Somewhat limited memory in those old flip phones. Tania has taken 16 pictures already, so that's what we know already. So let's make a plan. Write an inequality. We're going to let P represent the remaining number of pictures Tania can take. So let's go ahead and think of this as the number taken plus the remaining is at most 20 pictures. So there's a statement that we made with our known information. Now we're going to convert it over to a mathematical sentence. The number taken we know is 16. Plus is addition. The number remaining we're going to represent with the variable P is at most. So we're talking about less than or equal to, right? If something's at most, then what's on the left needs to be less than what's on the right. So we have less than, and it can be 20, so we have equal to. In this case, 20. We fill that in. So let's go ahead and solve. 16 plus P is less than or equal to 20. Well, let's get rid of this positive 16 with a negative 16. Whatever we do to one side, let's do to the other. The 16s cancel each other, leaving us with just P on the left. 20 minus 16 is 4. It is not reasonable for Tania to take a negative or fractional number of pictures. So graph the non-negative integers less than or equal to 4. Think about it. Can you take a negative number of pictures? No, you can't. Can you take 1.5 pictures or 2 3/4 pictures? Can't do that either. You're going to take 1 picture, 2 pictures, 3 pictures, 4 pictures, or possibly no pictures. So the solution is that Tania could take 0, 1, 2, 3, or 4 more pictures. So notice how this graph is a little bit different than the other graphs. There's a concept of continuous and discrete. This would be discrete. We'll talk about that later on in another lesson. So let's look back. First, we're going to check the endpoint by plugging in our solution of 4. We're going to write it as an equation instead of an inequality. 16 plus P equals 20. That's the related equation. It's related to the inequality that we had here. We say it's related because it's pretty much exactly the same, but instead of an inequality symbol, we're using an equal sign. So we plug that in. 16 plus 4 equals 20. 20 indeed equals 20, so our endpoint is correct. Now let's check a number that's less than 4 to make sure that we have the correct inequality symbol. Think about it. A number less than 4, why not 2? 16 plus 2, 16 plus 2 is 18. Is 18 less than or equal to 20? Indeed it is. So adding 0, 1, 2, 3, or 4 more pictures will not exceed 20. Here's a sports application. Josh can bench 220 pounds. He wants to bench at least 250 pounds. Write and solve an inequality to determine how many more pounds Josh must lift to reach his goal, and then check your answer. We're going to let P represent the number of additional pounds Josh must lift. So we're going to represent that with the statement that it is 220 pounds plus any additional pounds is at least 250 pounds because we want to get to 250 pounds or more. So what is on the left side of the inequality should be greater than or equal to what's on the right. So on the right, we have the 250 pounds because, well, Josh wants to get to the point that he can bench more than or equal to 250 pounds. So let's go ahead and write this statement into a mathematical sentence. 220 pounds we'll represent with 220. Plus is addition. Additional pounds we're representing with P. Is at least would be greater than or equal to. And then 250 pounds we're going to represent with the value of 250. So we end up with 220 plus P is greater than or equal to 250. And we have that written here. So we have a positive 220 pounds that's up here with the P. So let's get rid of that positive 220 with a negative 220. What we do to one side, we do to the other. The 220s cancel each other, leaving us with P on the left. And 250 minus 220 is 30. So P is greater than or equal to 30. So let's check our endpoint. We're going to use a related equation. Same thing we have here, only instead of an inequality, we're going to use an equal sign. So 220 plus P equals 250. Let's substitute the endpoint of 30. 220 plus 30 is 250. 250 equals 250, so our endpoint of 30 is indeed correct. Next, we want to go ahead and check a number that's greater than 30. They choose 40. So 220 plus 40 is 260. Is 260 greater than or equal to 250? Indeed it is, so we have the correct inequality symbol. Josh must lift at least 30 additional pounds to reach his goal. That brings us to our guided practice. So number 1, and I'm probably just going to do a couple examples from number 1. Let's do 1, 3, and why not 4? We'll try to get 3 of them in there. So we have 12 is less than P plus 6. So we have the positive 6. Let's get rid of that with a negative 6. And what we do to one side, we're going to do to the other. The positive 6, negative 6 cancel each other out, leaving us with P on the right. And 12 minus 6 is 6. And we have our symbol of less than. Now, if I were to graph this and I want to know which way the arrow goes, I'm going to put the P over here on the left and the 6 on the right. And here, the symbol is pointing to the 6, so I want it to continue to point to the 6. So I would get P is greater than 6. I'm not going to go ahead and graph these. We would know that we would find an endpoint of 6. It would be an open dot, and it would go to the right, everything greater than 6. On the next one, let's do number 3. We have negative 5. And to that, we're going to add the value of x, and that should be less than or equal to negative 20. So let's get rid of this negative 5 with the positive 5. Let's add 5 over here. And what we do to one side, we're going to do to the other. The 5s cancel each other, leaving us with just the x on the left. Let's bring down that less than or equal to sign. Negative 20 plus 5 is negative 15. And indeed, our variable is already on the left. So if we were to graph this, here I go. Now I'm going to go ahead and graph. After I said I wasn't going to graph it. So I'd find negative 15, and it can be equal to it, so it's going to be a solid point, and then it's everything to the left, so we'd shade that in, and that indeed is everything that is less than negative 15, or equal to, because it's a solid dot, right? And then finally, let's do z minus 2 is greater than negative 11. So z minus 2 is greater than negative 11, so we have this negative 2 here, or if you want to think of it as the 2 is tied to the z through subtraction. The opposite operation is division. No, it's not. It's addition. The opposite operation of subtraction is addition. We're going to add the number we wish to get rid of, which is 2. And what we do to one side, we're going to do to the other. Or if you want to think about it as using a positive 2 to get rid of this negative 2 here. The 2's are going to cancel, leaving me with z on the left. And bring down my greater than sign. And negative 11 plus 2 is going to be negative 9. So if we graph that, we would find negative 9. It's going to be an open dot because we don't have the equality concept there with this statement. It's just greater than. And then it's going to be everything to the right, which is everything that is greater than negative 9. All right, so that is my complete presentation of Algebra 1, Chapter 3, Lesson 2, Solving Inequalities by Adding or Subtracting. Thank you.